the materialized views that I am going to explain are actually advanced features of the database. So not actually all databases support these. Like Oracle, they have a lot of advanced features. They are pretty aggressive, so they create these new features and immediately add them into their database. But if you look at some of the open source databases, probably they might not have all of these features. So just wanted to introduce to you that the relational database is not the end of the database. Okay? If you just understood the relational model, that's the very basic beginning of the database. There's many more advanced features that are supported by the database. Okay? So we've looked at object relational features, which means you could put objects into the database along with the code related to objects. The second thing we've looked at was triggers. And triggers meaning you could do automatic things when the database has some actions. Okay? So if some update occurs, insert occurs, and you want something to automatically happen related to that event, you could create triggers. Okay? So if somebody tries to do an update, you can put in some security code. You can put in some monitoring code. Okay? So that makes a lot of things, much more easier to actually implement. Another thing in the database is what are materialized views. And actually, this is one of the techniques of what we call a data warehouse. Probably you've heard about the big data keyword. Actually, in the later part of the class, I'll try to show you a simple kind of clip of video later on, and it shows, it's a basic kind of introduction of how important data is becoming. So data is flowing, it's being created. Now they're talking about not only petabytes, they're talking about zettabytes. Okay, so there's enormous amount of data, and these data are eventually going to be stored in very large databases called data warehouses. Okay? So a data warehouse can accumulate large amounts of data, and inside the data warehouse, one of the important techniques is the materialized views. Okay? So what this materialized view does is it is a pre-calculated result of a query. So let's say you want to calculate the average of the score of all of the students in Ewha. Okay, the average of all of the students, the GPAs. Okay, then probably that may take, if it's a very fast database, actually, just calculating for Ewha doesn't take that much time. But if you have a large body of students, then probably that could take several hours, okay, several days. Now, you don't really want to wait that much, a long time to just get a single answer, saying 3.01 or something like that after 2 or 3 hours. So what materialized views does is it will calculate the results before somebody asks for it. Okay, so the system monitors and finds, oh, the user asked this query a lot. Okay, this query is very frequent. Then what it does is it will run the query before the user asks for it. Okay? Probably, so today I asked what is the average GPA. Tomorrow I ask the average GPA again. So the system will calculate the average GPA before tomorrow. Okay? And it will provide it as a result for the next day. So by pre-calculating the result, your queries look like they're running more faster. Okay. You have the result already, and the system just returns the result. Okay. So that is what we call materialized views. The result is in a view form. That's a query, but it's materialized. It is already calculated. Okay. The results of an SQL query are stored in a table and used for later query processing. So you calculate the result, put it into a table, and then from this large table, you calculate this result, and this result could immediately be used when answering a query. Okay? Previously, you would have to run the query on all of this and return the result, but now, because this is a pre-calculated result, which we call the MV, the response time is going to be fast. Okay? You ask for the average, that's 3.01, just return it. Okay? That takes probably 0.001 seconds. This probably takes 1 hour. Okay? So, these MVs are basically a summarization of the data. You have the average, that's a summarization, okay? Or a sum, you could calculate the sum of the GPAs, okay? Now, what happens is, when somebody sends a query to the system will rewrite the query and change the query to use the materialized view instead of the original table. Okay? So, when the user came in, he actually asked for, give me the result of Q1. Okay? So the query says, read table X and get me the result. But inside the system, we'll rewrite the query and turn it into Q2. So the Q2 actually is a query on this table, on the materialized view. Okay? So inside the system, when somebody sends a query like this, the system will automatically change it to another query and run this query on the MV. Okay? So it's tricking the system. Okay? At the compilation phase, it will change the query. So when the query executor executes the query, it doesn't really know the original query. It just finds this query and it will just run on the MV. Okay? So the query rewrite mechanism is used in materialized views. Materialized views also need to be refreshed. So if you have some average calculation here, actually, pre-calculation means that you have some errors. Okay? Actually, I calculated 1 day before, but if there's any change between that 1 day, then there's a difference between the real calculation and my duplicate calculation. Okay? So between tomorrow, if somebody's GPA changes, then you have the wrong data, actually. Okay? So, but that could be a very small error. Okay? So usually that much amount of error is tolerated in the systems. Okay? So what happens is usually there needs to be a refresh when data in the tables actually change. So if somebody's GPA changes, then what happens is the MV actually needs to be changed as well. Okay? somebody's GPA changes, then automatically refresh the MV. Okay? So refresh mechanisms, query rewrite mechanisms, these things need to be handled by materialized views. Okay? But there are some good things and bad things about the materialized views. It takes some space and maintenance cost. Okay? So because you are using extra space here, the MV takes up some more space. Okay? Also, there is some maintenance. You have to refresh it. Okay? So that's refresh cost. So maintaining MVs might speed up your queries, but if you create too many MVs, what happens is you take too much space and you need to have a lot of maintenance. Okay? Your maintenance time goes up. Your storage requirements go up. So, you know, if you can anticipate all the queries, you could probably create all MVs, but that really doesn't help. Okay? If you have limited space, you know, you also want to don't have too much maintenance time. Okay? So those things have to be considered when you create materialized views. Okay? So this is one of the actually important techniques that are used in you know, very large data warehouses. And as big data is becoming important, people want to actually do complicated operations on large amounts of data in very fast time. So one of the ways to do that is using materialized views. So, 요즘 그 빅데이터 이슈가 나오면서 굉장히 중요한 내용이라서 간단하게만 서머라이즈하면 구체화된 뷰라고 이렇게 보통 한국말로는 이제 번역도 합니다. 뭐냐면 어떤 질의 결과를 미리 계산한 거다 이렇게 생각을 하시면 돼요. 그렇죠? 한 뭐 수억 명의 그 학생들의 성적을 다 평균한다. 1시간, 뭐 2시간, 며칠 걸릴 수도 있는데. 질의 결과를 만약 미리 계산해 놓으면 이런 질의가 들어올 거다 미리 예상을 하고 그거를 계산해 놓을 수 있다면 이제 MV라는 테이블로 만들어 놓는 거예요. 그래서 미리 한 몇 시간 전에 계산해 봤더니 3.01이더라. 딱 한 개의 값만 딱 달랑 유지하고 있으면 되죠. 그래서 실제로 그 질의가 들어왔을 때 그 질의를 수행하는 게 아니라 얘한테 가가지고 결과만 달랑 가져오는 거죠. 그러면 뭐 0.001초 만에 결과가 돌려줄 수 있겠죠. 그렇죠? 근데 실제로는 이걸 수행하려면 한 몇 시간, 며칠 이렇게 걸릴 수도 있죠. 그래서 문제가 되는 것들이 이제 여기서 이게 이제 주로 요약 데이터를 많이 저장을 하고요. 그래서 summarize 데이터. 그 다음에 query rewrite라고 하는 거는 실제 질의를 살짝 바꾸는 거죠. 그래서 시스템 안에 질의를 던지면 얘가 너 MV 만들어 놓은 게 있네. 이거 갖다 쓸 수가 있겠구나. 그래서 그 질의를 MV를 쓰면 MV의 테이블 이름이 있습니다. MV 테이블을 셀렉트하는 걸로 바꿔줍니다. 살짝 속이는 거죠. 우선 그 MV에 대해서 실행을 하고 결과를 돌려줍니다. 그렇죠? 그걸 보고 우리가 퀘리를 다시 제작성한다. 그래서 질의 제작성, 퀘리 리라이트라고 하고요. 그 다음에 이 MV가 시간이 지나면 원래랑 얘랑 이게 동떨어지겠죠. 예를 들어 누구 GPA가 올라갔다. 그죠? 그러면 얘는 아직 반영이 안 됐죠. 그래서 업데이트를 해줘야 돼요. 그걸 MV를 리프레시 한다고 합니다. 그래서 이걸 주기적으로 이제 업데이트를 해줄 수도 있고 또는 이제 이거를 이제 온라인 업데이트가 생겼을 때 바로 업데이트 해주는 경우도 있고 이제 몇 가지 방법들이 있습니다. 그래서 예를 들어 사람들이 이제 다 퇴근한 뒤에 시스템이 놀고 있을 때 주말에 몇 시간 동안 계산해서 업데이트를 해놓기도 하고 실제 나가보면은 회사나 이런 데서는 주로 그 주말에 그런 컴퓨테이션을 미리 합니다. 일주일 동안에는 약간 데이터가 좀 어긋나도 그 다음 주말에 또다시 일치가 되죠. 그렇죠? 그래서 그 정도는 이제 허용이 되기 때문에 워낙 데이터가 많다. 근데 이제 당연히 그 MB를 만들면서 추가적인 공간이 필요하고, 그다음에 이렇게 업데이트하는 그런 유지 보수가 추가적으로 필요하죠. Okay, so we've looked at some advanced features, and now let's just quickly look at the system architecture. Of course, all databases don't have the same architecture. Okay? So this is just for some information, you know. And if you look at the Oracle system architecture, you can kind of establish the Oracle server in different kind of modes, like a dedicated server. So there's an operating system process that is dedicated to each SQL statement. You can configure it as a multi-threaded server. So an operating system process can be shared among multiple statements. Okay, so multi-threaded means, you know, the server is threaded, so it has parallel processing that is capable, and it can be working on multiple statements at the same time. So, well, of course, a lot of servers, if you need to be a server, you know, you have to have these multi-threaded capabilities. In Oracle, what they kind of have as a nice feature is called RAC, R-A-C, Real Application Clusters, and that's where the name, the G part came out, grid computing. Okay? So grid computing means you can run the software on several nodes, and they look like they are one system. Okay, so that's grid computing, and the good thing about grid computing is it's very scalable. Okay? So if your organization right now has 100 employees and you can work with 2 nodes, then later on if your employees go to like 1,000 employees, then probably your system on 2 nodes, you know, will not work, you know, with that much performance. So then your employee went from 100 to 1,000, that's 10 times. So probably you use, instead of 2 nodes, you go to 20 nodes. Okay? So if your system wants to go from 2 nodes to 20 node database system, it has to work on a grid. Okay? So if you use grid computing in the Oracle feature, then you can scale, they say infinitely, but probably not really infinitely. Okay? So, and the grid part they call RAC, Real Application Clusters. Okay? So this is their name for their grid platform. So multiple instances of Oracle can run against the same database. There's scalability, so you can run the database on, you know, as much nodes you want. High availability. If one node fails, other nodes are available. Okay, if 1 or 2 nodes fail, still the database is running. Of course, there are some very complicated locking and cache management issues. So, because the data is everywhere, you know, if you have to do locking, it's very complicated. But actually, that's their patent technique. So, actually, only the developers of that really know how that works. Okay, so they call that cache fusion. Okay, that's patented technology, and using that cache fusion, the nodes can scale almost infinitely. Okay. So, you know, right now they have 10G, 11G, and this is actually grid computing, which actually in Oracle, their system that supported is RAC, Real Application Clusters. Now, has anybody went to the database, the event last week? Did anybody get a new iPad? Okay. Well, anyway, if you work in a database career, there are several paths, and one of the paths would be a DBA, database administrator. Of course, you could be a developer. Of course, you could be, so developers would develop codes and all those things. You could be an architect, database designer. So that's actually a very high level in the database. So basically, you design the tables for your database, and you know how the system works, you know how the requirements work, and based on those requirements, you are able to design the tables very efficiently, and because the schema of your database is the most important thing of how your database will work efficiently. If you have the wrong schema, then you'll have a lot of problems. Okay? So an architect for the database has a very high position, and basically design the schema of the database. Another kind of role that you could do is a database administrator, and a lot of people also like this kind of path because that's what we call a DBA. So you're basically administrating the system, monitoring the system. You want to see some performance issues. You manage the users, manage the tables, and actually you do a lot of things at runtime. So starting from creating login accounts for users and monitoring the performance of tables. And if you need to do things, you could speed up some processes. Sometimes you could also add some, indexes or those kind of things if you're a DBA. So basically, there are a lot of tools that support the DBA job. And the good thing is you can also be a DBA for a long time. Okay? So once you have the experience, experience is what counts a lot, and you can do it even if you're very old. Okay? So a lot of people who are DBAs in Silicon Valley still have jobs even they're old. Okay? They go from company to company, get the stocks, get some money, and then move, and then so continuously just work on a DBA and manage the data of their companies. Okay? So a lot of people like to be DBAs. Oracle Enterprise Manager is one of the tools that you can use to manage the database system. So here you can do, it has a very nice graphical user interface. You can do schema management, security management. Instance management means the database instance. Storage management, job scheduling, performance monitoring tools. It has a lot of nice kind of tools in this manager. Also, there's a database resource management tool, which allows the administrator to divide users into resource consumer groups. Okay, so you can manage the users, and also internally, some SQL queries can be managed by setting time limits on how long the SQL query can run. The number of user sessions can be limited if you have too many users, those kind of things, based on the resource. Computing resource could be managed. Okay? So there are very nice tools provided by Oracle. Of course, also there are some very nice tools that are created by third-party companies. So if you look at some very small companies, actually they can actually be installed very easily. They can still do very similar things that the Oracle tools can do, and they're actually very nice companies to work at actually. So we've kind of looked at some of the database essentials, and questions at this point? So I guess it was a kind of extensive database essentials kind of thing, and we kind of looked at several things. The most important things that you should probably understand when you're creating your database applications are you have to understand about some transaction concept. Okay, so that will be one thing that you'll actually also see in the JDBC codes. Another thing is, like, when you're creating database tables, think about your performance. Okay, so one of the things that is very important would be, understand indexes. Okay? So what are indexes, and when you create your database tables, try to create indexes together.